to be here in front of you. We are a team under the guidance of Professor Chung Mi-suk of Nanosemiconductor Engineering. Today we are going to talk about floating technology, which is our topic of graduation project. Our team consists of 3 people: our team leader Park Jae-ru, Choi and myself, Kim Ji-won. Here are the contents of our today's presentation. We'll divide our presentation into 7 parts like this. Okay, let me start our presentation. I'm gonna start with the background at first. In the beginning, I was going to talk about floating technology. Then you might ask, what is floating technology? To be short, floating technology is a kind of technology for projecting the image in the air. I mean, by projecting a picture or video onto the half mirror screen, you can see the virtual image looks like floating. Since we can show the image with high sense of reality, floating technology is being used across a range of industries like concert or musical. Look at this graph. This graph shows that the number of patents using floating technology has increased steadily every year. There is a reason why we choose floating technology for our topic. And then we thought if floating technology can present through Google type devices like via Google, it could enhance not only the level of immersion, but also the user's accessibility. It could also help us to focus on the image to do activities like this. And just by editing video, we could create various types of content, and it makes us to use it more accessible. However, so for existing technology, there is a huge problem that the size of the virtual image is same as the object. So we have to use the same size mirror with the image. That means if you want to make the bigger virtual image, like main size image, you have to prepare the much bigger sized half mirror. So we had to find a way how to get the magnified image by using the small half mirror. Then how are we going to make it? Let's move on to the details of our design.
Hello, I'm Chasing here, the next presenter. Let me tell you about our product composition. Our product consists of cell phone, half mirror, eyepiece lens, and case. We are using our cell phone as a light source and designing it. Using cell phone as a source of light will make it easier for a consumer to see what they want to see. Through our product, we can see the video of the cell phone as a virtual image on a screen rather than the actual cell phone screen. We also use the half mirror with 50% transparency and 50% reflectivity to show calorie virtual image. The optical system scale of the virtual image is 1.5 times larger than the existing cell phone and will be designed to give an excellent sense of immersion. We designed the optical system using Synapse Optical Studio program. The case will be manufactured through the SolidWorks programs and will be manufactured by introducing one touch hold for using various cell phone models. The picture of the presentation is a draft of the case of our product made of SolidWorks. The next is our product applications. Consumer can enjoy high quality leisure and their hobby through our product. For example, we will be able to enjoy the game more vividly like this picture. Also, consumer can watch the video the high level of immersion through our product life-size consort. The next is about optical system. This picture, the presentations you see here, is layout of the overall optical system. We are going to use 2 lenses and 1/2 meter for designing an optical system. We will design high resolution eyepiece lens to make quality virtual image. Also, we want to introduce the concept of eye box and proceed with the design considering the different eye position for each user.
What did we reach on our goal through the initial design laser? We reached to objective in dispersion and lens diameter. We focus on the light weight of the product and MTF. MTF is standard of contrast. High MTF makes the image clear. Those are important in wearing an optical system. Lightweight is related to the persistence of wearing. It is important to users' comfort. Thus, we try to design using the minimum lens. How to design considerations for the various location of users' eyes. We take a multi-configuration function in ZMax. What is the multi-configuration? Please look at the presentation. It helps you to understand what multi-configuration is. Multi-configuration sets many locations of the eye on the eye box area. It can make to calculate aberrations on many locations of stop areas. 7 circles locate on the eye box area. It was designed for exact calculation. How to evaluate the success of the product? We already made a standard for evaluation. It contains all our objectives. We will evaluate our product based on this table below. Let me introduce the key specifications of our prototype. I want to tell you everything, but I do not have enough time at this time. Look at this table. We set objectives. For example, eye relief, upper 10 millimeters or 20 millimeters, and MTF, upper 0.6 at 18 LP per millimeter. The total length of half mirror to the first surface lens, first surface 60 to 80 millimeters. Lens diameter limit under 40 millimeters. Eye relief and total length of half mirror to the first surface lens diameter is set for the light of product. MTF is for clear image. We are in March. We have collected many data and analysis for lens design. We are designing the optical system every day. We already started the simulation of the optical system. We got a positive result. These days, we are trying to fix the problems with lens specs. We will make a prototype as soon as possible. It is our goal. Thank you for sharing your time with our presentation. I hope our thinking and expressions delivered to you precisely.